This is connected up between the live and neutral. So basically that's doing the test that we would do with a neon screwdriver to show you that the mains is on. Obviously it's a neon, so it's bidirectional. So that is showing you that you've got mains present on between the live and the neutral, which may be all you need. But the problem with this is it doesn't differentiate between whether the live is coming in on the live or on the neutral. Just to explain that. If that's our incoming AC mains, and I've shown the live outlet pin as being on the right there and the neutral on the left. So let's say that's our incoming wires from the AC mains, and here's a representation of a neon connected up between red being live, blue being neutral. So that's what we have here. But if we reverse the supply, makes no difference to the neon, it's still going to light up. So even with the live connected to neutral and vice versa, i.e. a dangerous situation, we're still going to show that mains is available. Well, that's a useful thing to know anyway. If you put a neon across the two, when you've got power applied, 220 volts difference between your live and neutral, the neon's going to light up. If you put two in series, the same will happen. They only need 90 volts each to strike, so there's plenty of potential between the two to light up. Okay, now we do it with the earth. The same. These are connected together, but they're not connected to earth. So when the mains is on, they'll light up. If we connect them to earth, where they join, so it might be a bit clearer if I do this. So effectively they're still connected to the same point in the center, but to earth now, instead of just across like this. Now I'll point out what's going to happen before it happens. If this is live, this one here is going to see a potential difference of 220 volts, and it will strike, light up. This being neutral, 0 volts is the same as the earth line, the ground, so it won't see any difference in potential and it won't light up. So if everything is correct, if you've got an incoming live on your live and a good earth, then only this side will light up. In my case, I've got two neons that come in a bezel that you can panel mount. This is just a blanking plate for a single unit electrical outlet. So it's easy enough to drill a couple of holes and mount something like that in it. For my demonstration purposes now, I'll just stick them in a bit of cardboard. The other thing is that I'm showing it mounted in a little box. You can get all sorts of little insulated boxes to be able to put a couple of neons in, but if this is going in a recreational vehicle, a camper, motorhome, something like that, then you should have a consumer unit inside. So then the ideal place to have these neon indicators is actually mounted in or next to the consumer unit, so that you can see at a glance the status of the mains coming in. What I also have on mine is a Spanish unpolarized outlet. So that allows me, I have no idea, it's a toss of the coin whether live is connected to live or is connected to neutral. Move that out of the way. So let's find out. Right, well, they're both lit. So that says straight away that there is no earth. That's the situation. So they're each getting part of that potential difference between the live and the neutral. This is the halfway point. They're each getting half of the voltage, so they're both lighting. So the red one is this one here, is the way I've connected this up. The red one is connected up to, between the neutral line and earth, and the green one is connected up between earth and the live. Well, there is no earth, so they're effectively just connected together and they're both lighting. So if the red one lights, there is a problem. It's seeing a voltage difference across it, which it shouldn't be if it was 0 volts. I can show that now because I've put a switch in the earth line, and I'll switch the earth on there. And now you can see straight away that now that it is earthed and not floating, there's no potential difference, and you get your full 240 volts, 220 volts across your live to your earth. There's no current consumption, so you won't trip out a 30 milliamp earth leakage circuit breaker. But it does show clearly on the green side that you have live on the correct live side, and you have an earth. If you didn't have an earth, the red error light would come on as well. Now, I can show this easily on this test rig, that if the main supply was connected up incorrectly, just give it an earth. Now it's the neutral side that is at live potential, so it's the red one that's lighting up, and the what should be the live is now 0 volts. It's the neutral, so it isn't lighting up. So if the mains is reversed, you get the error light come on by itself. This is assuming there is a good earth. If there was no earth, then again they would both come on. We're back to this situation. So just by having those two different colour neons, it's a very good, I can get rid of this now, a very good indication of the state of your mains. And by having, let me switch this back, so we've got an earth, but we've got the wrong polarity coming in on the pins. Well, okay, if you have an unpolarized socket and your consumer unit, your supply to your vehicle, is connected up via a plug, you can just, if it's not correct, you just switch it around. Now it is, and I know that there's a good earth. Prove that again. So those two neons let you know that your vehicle electrics, and it doesn't have to just be the vehicle, you could have this anywhere you want to keep an eye on your mains. If you're using generators, for instance, if it's a site somewhere and different generators come to power that site, maybe out buildings on a farm, well, this at least lets you know that the electricity supply is correct and is safe. A quick word on the neon mains testers. You can get them for £1. If you're going to get one, get two, because if I was to rely on that and touch things, I'd be in trouble, because I know that that one's faulty, this one isn't. So if you come to test and it doesn't light up, I have a second one nearby. They go together for me. So if one doesn't work, I'll try the other. It just proves, because eventually one of them probably will fail. The resistors crack eventually and go open circuit. So it just doesn't work. All you have inside is the neon and a high value resistor. It's 820k, this one, nearly 1 meg. So there's no current going through. You're quite safe. And they can't go short circuit, but it can crack and go open circuit and not work. So you think that the line that you're testing is dead, when in fact it could be live. One more point on this is, this is a very nice one, because it's got Phillips at that end and flat at that end. Well, that's great. Lovely. And it's a mains tester. Oh, well, wait a minute. It's a mains tester and you have all of that metal bare that's live. Well, this is sold from China for £1. And it does exactly its job, but it's not exactly safe. It's an accident waiting to happen. And if you're okay with that, well, don't blame yourself when something goes wrong. Well, there's no one else you can blame, actually, because all you need to do is put a bit of heat shrink on and you've improved the safety of that hugely. No one's going to tell you to do that. Well, I've just told you, but it's a matter of common sense. You need to look at the situation and decide, is that good enough? Or can you improve it for your own benefit? That's something that's up to you.